because we don't have enough height segments along the object. So one of the things I'd just like to quickly cover here very quickly is turbo smooth, which is a smoothing method to make this look a bit better. Now, a way to make this look better, and many other things, is to increase the number of segments along your object. Now, we do it here. There's no big deal with doing it like this in this case. It's fairly fine, doesn't have too much of an effect. But if you do this a lot, if you start out with a cylinder that's got lots of segments in it, it's very hard to edit if you convert to an editable poly and then move the vertices. You find it's very hard to edit because you've got to move so many faces, and if you find you have too many faces, you can't do anything about it. So what I find better is to use this smoothing modifier called the Turbo Smooth modifier. You can also use Mesh Smooth. I don't really know the difference between either one. They both provide similar things. Mesh Smooth is has a bit more advantages, and to my understanding, Turbo Smooth is a bit less CPU hungry, so I just go for Turbo Smooth. So now I'll notice that as soon as we applied Turbo Smooth, it made our object less blocky, and that's quite cool. So what it did basically is this, from this parameter here called iterations, which basically tells the Turbo Smooth modifier how many times it should do its job. So we're going to turn it up, 2, 3, 4, and you'll notice quite quickly, you don't even need to go all the way to 4, quite quickly that now it's an acceptable level of smoothing. And if we go to edged faces, you can see it's now got a large number of faces. But now here's another problem. Our cylinder has turned into a sausage. Because where our little edged end edges were originally, it's now also smoothed those in. So I'm going to show you a quick way to separate that bottom and top face from the rest of it. And you simply go into surface parameters, make sure that's checked, smooth result, and then separate by smoothing group. And you'll notice that as soon as we check that, our faces came back and it's a cylinder again. Now, the reason smoothing group works, I'm not going to go into it too detailed. I'll make another tutorial eventually about it. A smoothing group is basically a little ID that's put onto a face. It tells Turbo Smooth which faces to link together and which ones not to. So because this is a standard shape, a cylinder, still, instead of being an editable poly, 3ds Max has done the job for us automatically. And as you can see, basically, let's say this face, the top face, is an ID of 1, and then this side area has got an ID of 2. That means when you go to apply the Turbo Smooth modifier and separate by smoothing groups, it will know that since those IDs are different, not to match them together. If this was 2, however, and so was this, it would put them together. So yeah, that's pretty much it there. I don't think there's too much else I want to cover. Just one thing, taking this whole concept to a bit more of an advanced level, I just should also mention that in the case of path deform, 3ds Max doesn't do any auto keying for you. So if you want your cylinder to move along your path, you have to do it yourself. So you can just do it simply here. Now you'll notice as we scrub along, it does the animation, so it's still simple. It doesn't really make a difference, but just point that out. Alright, so now we're going to take this concept in itself to a more advanced level, where instead of having a line it moves across, we're going to make a patch for it to move across. So basically, like if you want something to move smoothly along a piece of terrain you've made or something, this is quite useful. So now we've made a patch here. I've gone to create geometry, patch grids, and made a quad patch. So now we're going to go to convert to editable patch, pretty self-explanatory. Go to this one, which is handles, and then we can move these about and just make it a bit more of a smooth sort of thing. Now I haven't really experimented much with editable patches. I don't really know too much about what they are and what makes them so special, but I just thought I'd include this in the whole thing because it sort of relates to what I just talked about and what we just did. So now we sort of make this, and this sort of kind of represents like a little hilly sort of environment. And let's say you've got a block which you want to move across it, make it move across it in a smooth way, so the surface of the block always matches the surface of the terrain. You could do this for a number of things. Like if you're making a landscape, you might want to be able to easily map a hilly environment on top of a plane to make like the sort of landscape you wanted. I'm not really sure. It's just for you to play with. Alright, so now we've got our patch or our terrain here. We're going to get another box to move across it. So now for this, obviously, as you may know, the more faces your box has, the more accurate the matching is going to be. So we're going to turn up our segments on our object. So we're going to go to like 5 or so. And we don't need to worry too much about height because we're not affecting the height in this case. So now we go to our modify list, and instead of selecting path deform right here, we go to patch deform, and then we just do what we did before. Pick patch, click the patch, screw it up here, that's okay, click move to patch, and you're done. Now, I didn't mean it like that, but it seems that my box almost exactly matches my patch in terms of length. And you can change the percentage along the patch in X and Y direction, or in this case U and V. I think that might be something to do with the whole UVW map thing. I don't know what those mean, so just Google that in your own time. And so you can change the position along this axis, and as you can see, as we change the position, it will move along quite smoothly. And also, if we change it along the other position, it should match it as well. Now, the important thing to notice is that once it leaves the patch, it doesn't go back to its regular position as we saw it as a box. It continues along basically in freeform. Yeah, so you might just want to control that ever if you're using it. I don't know if you'll need to or not. But yeah, let's see. Editable. Path deform does the same thing as you might have seen when I was moving about the cylinder. So yeah, I mean, I'm not sure what you're going to use this for, but I just thought it might be helpful. Now, the reason which I found path deform particularly useful in my case was because I used it to make like a little circle of light, which expanded and sort of like the reason I used path deform in particular was because my sort of emitting object was a cylinder which was varying in width along it, which meant that the circle, when I applied it to path deform, would have changing brightness. And then I made this rotator around it and just made it a bit easier to do the job. So I've got a video here, so this is some of the sort of things you can do if you apply path deform correctly. So now, I mean, you can use like light circles for, like, if you made a light circle, you could use it like a shockwave or something. Like I used it for a shockwave, but you can just use them for lots of things. You can use path deforms to do this sort of thing, to make snakes, and do whatever you want, really. It's free world. Alright, no worries. So hopefully what I've shown you has helped you a bit in what you want to do. And yeah, see you later.